If your science textbooks still say, "No one knows how tunneling works," you're overdue for an upgrade. For decades, students and even seasoned physicists have stared at those same lines, wondering if we'd ever get a real answer. Quantum tunneling has been one of the most mind-boggling, counterintuitive phenomena in all of science, a riddle that's stumped generations. But now the story is changing. The textbooks of tomorrow will tell a different tale, one where the impossible becomes possible and the invisible is finally revealed. This quantum mystery just got cracked wide open. After a century of speculation, frustration, and wild theories, scientists have finally pulled back the curtain on one of nature's most elusive tricks. It's a moment that feels almost cinematic, a plot twist in the story of physics that no one saw coming, but everyone hoped for. The sense of discovery is electric, and the implications are enormous. Let's dive in. Here's the deal. Quantum tunneling is like the ultimate cheat code in physics. Imagine you're playing a video game, and your character suddenly walks through a wall as if it's not even there. That's what electrons do, but in the real world. It's as if the universe has a secret back door, a hidden passage that lets particles break the rules we thought were unbreakable. This isn't just a quirky footnote in physics. It's a phenomenon that underpins everything from the sun's nuclear fusion to the microchips in your smartphone. Tiny particles, like electrons, somehow slip through barriers that should be impossible to cross. According to classical physics, if you don't have enough energy to climb over a wall, you're stuck. But in the quantum world, particles don't play by those rules. Instead, they act like waves, and those waves can leak through barriers, appearing on the other side without ever going over the top. It's as if reality itself is a little fuzzy at the edges, allowing for miracles to happen on the tiniest scales. For a century, it was pure magic. We knew it happened, but nobody could see inside the tunnel or explain what really went on. The best minds in physics could only guess, using abstract math and indirect experiments. It was like trying to solve a puzzle with half the pieces missing. The phenomenon was so strange, so outside our everyday experience, that even the experts sometimes doubted their own calculations. The tunnel was a black box, a forbidden zone where the rules of reality seemed to break down. Since the 1920s, brilliant minds like Schrödinger and Einstein puzzled over this. They debated, argued, and sometimes even threw up their hands in frustration. Schrödinger, famous for his cat, tried to use wave equations to describe what might be happening inside the tunnel. Einstein, ever the skeptic, called tunneling spooky, and doubted whether nature could really be so strange. Yet, experiment after experiment confirmed that tunneling was real, even if no one could say exactly how it worked. The greatest thinkers of the 20th century were stumped, and the mystery only deepened as technology advanced. All we had were equations and guesses, no actual peek inside that forbidden zone. The math could predict the odds of tunneling, but it couldn't show us what an electron actually did while it was inside the barrier. Was it moving? Was it standing still? Did it even exist in a way we could understand? The lack of direct evidence left physicists in a state of perpetual curiosity, always searching for a way to shine a light into the darkness. It's like trying to watch a movie, but your TV only shows static. You know there's something happening behind the noise, but you just can't see it. For decades, tunneling was a story told in shadows and hints, never in clear images. The frustration was palpable, not just for scientists, but for anyone who wanted to truly understand the quantum world. The tunnel was a place of mystery, a realm where our best tools and theories fell short. But now, science just leveled up. Thanks to a new generation of technology, ultra-fast lasers, ultra-sensitive detectors, and mind-blowing imaging techniques, we can finally peer into the tunnel itself. It's as if someone handed us the remote and cleared up the static, revealing the movie that's been playing all along. The leap from theory to observation is nothing short of revolutionary, opening doors to discoveries we never thought possible. Thanks to new imaging tech, researchers finally caught electrons in the act, mid-tunnel. For the first time, we have direct evidence of what happens as an electron tunnels through a barrier, using attosecond pulses, bursts of light so short they make a nanosecond look like an eternity. Scientists can freeze-frame the action, capturing the electron's journey in unprecedented detail. It's like having a high-speed camera for the quantum world, revealing secrets that were hidden for generations. They mapped the electron's hidden path, turning theory into reality. For the first time, we can see not just that tunneling happens, but how it unfolds in real time. The electron's journey isn't a simple hop from one side to the other. It's a complex dance, a blur of probabilities and possibilities. By tracking these movements, researchers have transformed a century-old mystery into a concrete, observable process. The tunnel is no longer a black box, it's a window into the heart of quantum mechanics. It's like seeing a magician pause halfway through a trick and finally learning the secret. Why does this matter? Because understanding tunneling isn't just about satisfying curiosity, it's about unlocking new powers in technology, energy, and even our understanding of the universe itself. When we decode nature's magic tricks, we gain the ability to perform our own, building devices and systems that were once the stuff of science fiction. Because this breakthrough could unlock super-fast computers, insanely efficient electronics, and new tech straight out of sci-fi. Quantum tunneling is at the heart of modern electronics. Transistors, diodes, and even the latest quantum computers rely on it. By understanding and controlling tunneling, we can build faster processors, more secure communication systems, and sensors that detect the faintest signals. The future of technology is quantum, and tunneling is the key that opens the door. Electrons warping through barriers isn't just science fiction anymore, it's quantum fact. Mind blown? It should be. We're living in an era where the impossible is becoming possible, where the boundaries of knowledge are expanding faster than ever before. Every new discovery in quantum mechanics reshapes our understanding of reality, and tunneling is one of the most dramatic examples. The more we learn, the more we realize how much there is left to discover. Smash that like button and subscribe for more brain-bending science. If you love exploring the mysteries of the universe, you're in the right place. Every week, we dive into the weirdest, wildest, and most wonderful corners of science, from the tiniest particles to the farthest galaxies. Your curiosity fuels our journey, and together we're rewriting the story of what's possible. Which quantum mystery should we solve next? Drop your ideas below. The universe is full of secrets waiting to be uncovered, and your questions could spark the next big breakthrough. Whether it's the paradoxes of entanglement, the mysteries of dark matter, or the search for a theory of everything, we want to hear from you. Stay curious, keep questioning, and remember, in the quantum world, even the wildest ideas might just be true.